Welcome back to another exciting episode of Space Nuts. I am your temporary host, and this will be my last week here before you get your beloved Andrew Dunkley back. But my name is Heidi Campo, and I'm here with the wonderful, delightful, brilliant Professor Fred Watson, astronomer at large.
Oh, Heidi, you can come again. It's very generous introduction there. Thank you very much.
Oh, well, we're just excited to have you here, Fred. And yes, you are all listening to another episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And today on this episode of Space Nuts, we are going to be first and foremost talking about the conversation that is on everybody's mind. It's been the hot topic in space science lately. And no, it is not what you're thinking. It is actually talking about K2-18b, the planet. And we are going to be talking about all of the news that's real versus what's kind of fake. There's probably a lot of misinformation out there. So, Fred, let's start with just breaking down what's the big news about this planet.
It's big news that's been, I guess, a fairly long time coming, because this planet has captured the interest of astronomers and astrobiologists in particular, and they're the scientists who study the origin of life and whether there is life elsewhere in the universe. Because first of all, it's orbits in its home star. The planet orbits in its star's Goldilocks zone, the Goldilocks zone where it's not too hot and it's not too cold, but it's just right for liquid water to exist. The star itself, K2-18, is a red dwarf star, which means it's much cooler than our sun, and so this planet orbits closer to its parent star than we do, but it still has the right temperature for liquid water to exist. And in fact, it's been hypothesized that this was what's called a Hycean world, which is a world which is covered with a liquid water ocean and probably a hydrogen atmosphere. We don't know for certain that these worlds exist, but they fit the modeling, and so the evidence seems to be coming from K2-18b that it's a world like this, and partly that's due to earlier observations which showed concentrations of both carbon dioxide and methane in its atmosphere. So that has sort of put this planet on the kind of hit list of astrobiologists. It's made them aware of the fact that it's a planet that could just possibly harbor life. And so the group of scientists who've kind of hit the headlines with this story have used they've been using the James Webb Space Telescope, our kind of currently best tool for doing this kind of thing, in order to probe more deeply into the atmosphere of K2-18b, and by more deeply, I mean in more detail and with greater sensitivity. The James Webb Telescope's a 6.5 meter diameter telescope, so it's got good light gathering power. But it has to be said, and this is the caveat at the beginning of all discussions of this kind, that the observations that these scientists are making are very, very difficult ones, because what you have to do is look at the light from the star. Since you don't see the planet itself, all you can see is the combined light of the star and the planet. You look at the light from the star, you examine it with the spectrograph. That's the device that breaks the light up into its rainbow of colors and gives us this barcode of information about what's in the atmosphere of the star. And then when the planet passes in front of the star, you've got a tiny additional component that comes from starlight, which is passing through the atmosphere of the planet itself. So there's this tiny little ring of atmosphere that is superimposed on the disk of the star. We don't see any of that, but we know that's what's happening. And in that, in the atmosphere, that basically puts an extra dimension into the spectrum. It gives you a little bit more information in the spectrum, and you can deduce what is coming from the atmosphere of the planet and what's coming from the star itself. And so, to cut to the chase, the new observations seem to confirm, at a confidence level, they say, of 99.7%, which is pretty confident, but they seem to confirm earlier observations that hinted at two chemicals in the atmosphere of the planet, K218b, which are usually, and certainly always on Earth, they are generated by living organisms. The two chemicals are dimethyl sulfide and dimethyldisulfide, two with very similar names. Organic chemicals, carbon-containing chemicals. As I said, on Earth, they come from living organisms. And so that is the story as we know it to date. And of course, the excitement comes from the fact that if those chemicals are only, generated by living organisms on Earth, maybe the same is true on this so-called or possible Hycean world. Now, to put a sober touch on it, it's really difficult. First of all, it's really difficult to make the observations, and there's still some people who think that might go away, that the dimethyl sulfide and dimethyldisulfide aren't really there. And what will happen on that front is more observations will be made, certainly with the James Webb Telescope, and in a few years' time, we hope with the extremely large telescope, that European monster that's being built in the Northern Andes. So that's the first thing. The second thing is, can these chemicals only be produced by life? Are there other explanations? And a number of scientists have raised that as a possibility. They're saying, well, it's so hard to pick a biomarker, something that is an absolutely dead certain piece of evidence about biology. It's very hard to pick things like, that give you a rock solid case that you've got living organisms. And so what they're saying is maybe there are other natural processes that don't involve life, abiotic as we call them, abiotic processes that cause these chemicals to exist but don't come from life. And one suggestion is volcanic activity of a kind that we're not yet familiar with. And so I loved it, one of the comments in one of the news articles. You might have seen it too, Heidi, that this might not be Vulcans, but might be volcanism, which I thought was quite neat. So that's the story so far. And it's one of these stories that I think will evolve over time, as it has done already. And maybe we'll cover it on Space Nuts when the news breaks, if it does.
So tell me what the timeline of this evolution could look like. We are building satellites that can give us more information, but we're really kind of just holding here. We're sitting here on the edge of our seats waiting for this information. So the satellites will tell us more, but with how far away this planet is, and I forget how far away you said it was, how long would it take for us to get a probe there to even collect soil samples?
Okay. That's a really good question. Its distance is 124 light years. So with the fastest available spacecraft we have at present, we'd be looking at more than 1 million years to get there. I did the calculation. I did it in my head, actually, so it might be wrong, but it is at least 1 million years. It probably.
So remember that part earlier when I said the brilliant, wonderful? That's what we're talking about right here.
Well, it's. I'm thinking of, it would take about 60,000 years with a spacecraft like New Horizons, which for a while was the fastest human-made object traveling through the solar system. It would take about 60,000 years to get to Alpha Centauri, the nearest of the stars, and that's 4 light years away. So you can do the calculation.
Yeah. So that's not happening anytime soon. But with a lot of the new technologies coming out, maybe we will see the possibility of soil sampling in our lifetime. I know I was just at the Texas Space Grant Consortium Design Showcase this past weekend, and there were some really, really cool engineering ideas being presented with nuclear propulsion and lots of other really cool things that we're really kind of just on the fringe of that we may have those breakthroughs very soon.
You're right. And I mean, in fact, breakthrough is the word, because the breakthrough funding body has set up, it's a foundation founded by gentleman, if I remember right, his name's Yuri Milner, who's a Russian billionaire who set up these foundations, one of which is called Breakthrough Starshot, which looks at the possibility of using light sails to accelerate a spacecraft to something like half the speed of light. And if you could do that, then you can get to the nearest star in, 8 years rather than 4 years. 4 years it takes light to come here. 8 years would do it. Then you've got to wait 4 years for the signals to come back to show us what we've found there. But yeah, as you say, a lot of technologies are in the mix. Very briefly, though, what will happen, I think, on the nearer timescale, more James Webb Telescope observations, I'm sure, of K218b. And as I said, when the extremely large telescope, with its 39.3 meter diameter mirror, comes online in 2028, you can bet your life this will be one of the first targets that they'll turn their spectrographs onto, just to see what else is there.
That's all really, really exciting. Fred, I am wondering if you could tell me and some of our other listeners who are just maybe curious a little bit about the operational side of these things. When we get some cool breakthroughs with this, do the researchers have to apply for grants with telescope time or satellite time to be able to look at these planets?
Yep, that's how it works. And those applications are, generally speaking, there will be a facility like the James Webb and an independent entity which will look at the merits of the scientific proposals that have been put forward for observation on the James Webb, and they'll basically give them their time based on merit. It's almost a cutthroat process. It's very, if you're a researcher, and I used to do this myself years and years ago, you have to, you're holding your breath when you know this committee is meeting, and you're holding your breath for what the outcome is as to whether you're going to get your nights of time as it used to be on ground-based telescopes. I think they have hours of time on JWST. You get 2 or 3 hours and you've done very well. So it's a pretty egalitarian process. It's really just based on merit, generally speaking, rather than who can pay or anything like that.
Yeah, I always think of the movie Contact, and I think it's every scientist's dream to just have this wealthy benefactor with unlimited resources show up out of nowhere and give you unlimited telescope time.
Yeah.
Roger, you're allowed to clear here also.
Space nuts.
Well, that is something that is very, very exciting. But as our next article says, there are other big surprises out there. And this is not the only exciting thing happening in space. So I wanted to kind of pivot to the next article that you had on the deck for today, which is talking about the perpendicular orbit around these pairs of stars. I mean, this kind of sounds almost like there's some black hole stuff going on here.
Maybe there is. Yeah, that's right. It's some results that have come from the European Southern Observatory, which we've indirectly just mentioned because they're the organization which is putting together the extremely large telescope at Cerro Amazonas in northern Chile. About 10 kilometers from that site is the site of, it's about 20 kilometers from that site, let me get it right, is a mountain called Cerro Paranal, which has got what is currently the sort of largest set of telescopes, and certainly the most effective set of telescopes in the southern hemisphere. The 4 telescopes of the VLT, the Very Large Telescope, and that is a very powerful facility. And some results that have come from that actually carried out by researchers based at the University of Birmingham in the UK, and they would have had to apply for time on these telescopes, as we've just been talking about. And I know it's a very rigorous process. It's quite a difficult thing to go through. Anyway, they have been looking at an object. Oh gosh, aren't we good at giving names to things? An object called 2M1510, open brackets A, B, close brackets B. That's the name of this planet. But it
sounds like Elon Musk's kid.
Oh yeah, don't go there, Heidi. It's a planet that is in orbit around not one star, but a pair of stars, and that I'm sure would be familiar to you as a science fiction aficionado. I never know how to pronounce that. Is it Tatooine?
I think, we think we've got it. Yes, Star Wars, the sand desert planet.
Yeah, so a planet orbiting a pair of stars. Well, that's exactly what 2M1510, etc., is doing. But the surprise that has come from this is the way in which it orbits. Exactly as you said in the intro, we've got two stars which are in orbit around one another. It's what we call a binary system, and these are very, very common throughout our galaxy. In this case, it's two brown dwarf stars again, the stars that are cool and a bit like the one we've just been talking about with that other planet orbiting around it. So we're doing two planet stories this week, but this is curious because the planet orbits the pair of stars in a plane perpendicular to the plane in which they orbit. That might not be very clear, but the two stars orbit one another. That defines a plane. At right angles to that is the plane in which the planet orbits. It's what we call a polar orbit. It's something that's very hard to understand, and the reason why is that we think that when planets form around a star, they form in a single plane, which is usually the same plane as which the star is rotating in. In other words, the equatorial plane of the star. And that's just because of the mechanism in which stars form. Now, if you've got a binary pair of stars which are orbiting one another, that defines a plane which probably had what we call a protoplanetary disk in it, where planets are being formed. But somehow this planet is not part of that disk. And it raises questions like, has it been captured from another solar system that passed by this pair of stars too close, and their gravity grabbed hold of this planet, put it into this weird orbit, and there it is as we find it today. I just one quote from one of the authors. They said, we reviewed all possible scenarios, and the only one consistent with the data is a planet on a polar orbit about this binary. The discovery was serendipitous in the sense that our observations were not collected to seek such a planet or orbital configuration, and as such, it's a big surprise. Overall, I think this shows to us astronomers, but also to the public at large, what is possible in the fascinating universe we inhabit. Quite poetic. I like what they've said there. They'll be working on mechanisms for which this has occurred, just to try and work out what the history of this unusual system is.
Well, it does look pretty spectacular based off of the, I guess, the artist renderings of what these orbital patterns would look like. And I guess, this is another one of those things we'll see. And it's, and it really makes me hope that we can continue to get plenty of funding for all the research that's going on, because while what's really exciting with K2-18V, that's going to take away from telescope time going on with this orbit pattern, right?
Yes. Yeah, that's right. Go ahead. No, sorry, Heidi. That is a really good point. That these resources are a limited they're a limited quantity. So typically on the telescope, I used to work on the Anglo-Australian telescope, the biggest one in Australia. For every night on the telescope, there were 3 or 4 different research groups wanting to use it. So telescope time is a limited resource. And if, like I was several times, you get washed out by bad weather, then you've just got to start again from scratch and compete with other sometimes perhaps better experiments that people want to do, measurements that they want to make. So yes, a limited commodity. The more telescopes we have, the better we can fulfill those requirements. But of course, the more expensive it becomes, and governments who tend to fund these things are not that generous when it comes to astronomical facilities compared with some of the more pressing demands on their public purses.
Yeah, and that's all something to consider. Depending on every nation that you're a part of. I mean, space is really becoming such a global economy, and I know we have listeners from all over the world. So, make sure that you're paying attention to what's going on in your country and how you can support the space industry as it grows.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And so it's kind of funny. I'm looking at our last article for today, and it's Easter Sunday for me, and it is Monday morning for you. I don't know if I will be able to live my whole life and still be able to wrap my head around the time difference of Australians. But my article for today and your article for yesterday, I guess, it was the Lucy probe flew around an asteroid, and it looks like its name is Donald Johnson is the name of the asteroid.
Yeah, Donald Johanson. Yeah,
Donald
that's
Johnson.
right. And it is I really like this story, actually, because it touches lots of little quirky things. NASA is so great at picking names for the projects that they do. So what Lucy is about, and this is a spacecraft, it was launched back in, I can't remember, it was 2021, I think, or thereabouts. It was launched in order to probe what we call the Trojan asteroids. And these are 2 clusters of asteroids which are in the same orbit as Jupiter, but bunch 60 degrees ahead of Jupiter in its orbit and 60 degrees behind Jupiter in its orbit. So 2 lumps of asteroids, and they come about because of these stable gravitational points that are beloved, actually, of Space Nuts listeners. We get so many questions on these. They're called the Lagrange points, named after the mathematician who discovered them in the 18th century. He discovered that they should exist. And they collect debris. And so Jupiter has, I think it's 7,000 in one of those 2 points and 9,000 in the other. It's a huge number of asteroids. There are the equivalent on objects in around other planets or orbiting co-orbitally with other planets. But Jupiter's is the richest of the Trojan asteroids, and of course that's because it's the biggest and most massive planet, more massive than all the other planets put together. Now, we've never visited a Trojan asteroid, and it may be that they have a different sort of structure from the normal asteroids that we find in the main asteroid belt. They might have different composition, different origins, different histories that we can interpret from measurements of their surfaces and things of that sort. And so the Lucy mission is going to visit Trojan asteroids, not just 1, but 7 of them. So it's going to do a kind of grand tour. And in fact, I think it's 6 in one of the clouds of Trojans and 1 in the other one. I can't remember which way around it is.
Quite the road trip.
Yeah, it's an absolute road trip. That's right. But on the way, they are flying by a main belt asteroid, and that's the one that we're talking about, Donald Johanson. Number 52246 is its number. Now, the backstory here is that Lucy got its name from that 3.2 million year old fossil skeleton of, I wonder if I could say, Australopithecus afarensis. Lucy, you probably won't recall, well, you definitely won't recall because you weren't born then, but back in 1974, this little hominid fossil was discovered in Africa, in Ethiopia, in fact, and given the name Lucy by basically the anthropologists and in fact paleoanthropologists who dug up the skeleton and found it. They called it Lucy, and the reason they called it Lucy is because the whole time that they were doing the dig and talking about this wonderful fossil that they'd discovered, it's a female fossil, it's only a few feet tall, they were playing the Beatles' Lucy in the Sky with Diamonds the whole time that they were digging it up. And so NASA picked up on this. They had a little nod to one of the instruments that the spacecraft carries, which has a fundamental part, which is a disk of lab-grown diamonds. So the spacecraft itself is carrying diamonds. So what else but to call it Lucy in the Sky with Diamonds? So that's a really nice touch. But I thought the clincher was that the asteroid that they're visiting on the way, as you've said, is called Donald Johanson. Donald Johanson was the lead paleoanthropologist on that dig to find Lucy. He's the person whose name is forever attached to the Lucy hominid, and his asteroid is sitting out there in space waiting for a visit by the Lucy spacecraft. I think it might have already happened, actually, as we're speaking. It was due on Sunday, I think probably Houston time.
So Donald finds Lucy, and then Lucy finds Donald.
That's right. That's a lovely, yeah.
Cute little roundabout thing of just, rocks and diamonds and all these fun little things in space. And what a fun backstory. Thank you so much for sharing that with us, Fred. So what do you think that they're kind of expecting to, or really hoping to find?
So it will be a flyby. So what will happen is we'll see lots of images. We will see the surface of the asteroid. I think Lucy flies by at something like 500 kilometers from the asteroid. So it's a close approach. We'll start to see details of its surface. As I said, there's a spectrometer attached to the spacecraft. It's been characterized as a carbonaceous asteroid, a C-type asteroid, which is one of interest because it's got high carbon content. What I was just wanting to check, and I think that's not the case, is Donald Johanson is 81 years old. He was born in Chicago, so he's still around and hopefully cheering the spacecraft on to the asteroid that is named after him.
That's wonderful. What a fun story. Do you have any planets or asteroids named after you?
I do.
Really?
Asteroid 5691 is called Fred Watson. Yes, it's all one word. Fred Watson. That was named in 2003, I think.
Must be quite the handsome asteroid.
I think it's. Do you know? I can tell you what its main characteristic is. It's totally boring, because it's just a main belt asteroid that orbits between the orbits of Mars and Jupiter. When we had news that asteroid had been named after me, which honestly I was blown away by. My two boys were quite young then, and I came home and told them they've named an asteroid after me. They said, "Dad, that's terrible. If it hits the Earth, it'll be your fault." And so they were quite, they were only young then, but it's a good point. But it never will. It's so boring; it'll never hit the Earth.
That's going to be the asteroid that we find some weird alien spacecraft on. That's where they've been hiding out this whole time. Then you'll go down in history.
That's right. That would indeed be the case. Yes.
Oh, excellent, Fred. This has been a really fun conversation, just talking about the most exciting discoveries. And we really got to talk today about, how these discoveries happened, and a little bit of the drama behind, the competition of getting that satellite time and that telescope time. And then, the fun, exciting, I think just kind of the tender, personable moments of this whole industry, people making discoveries and having things named after them, and just the tribute to people's hard work.
That's right. It's a global endeavor, all of this research in both space science and in astronomy. And it's a fairly close-knit bunch of people. And certainly there are only 10,000 astronomers in the world, professional astronomers, which is not that many when you consider how many people there are. It might be a bit more than that now. It's probably more like 15,000, but it's still a relatively small number. The space industry, of course, is a commercial industry, has much bigger numbers and ultimately more money. But nevertheless, the things that we do entwine so closely that we learn from each other. Each community learns from the other one. So yeah, it's nice to be able to talk about the way these things happen on an episode of Space Nuts.
Yeah, it's a kind of a space community, a space family, and we're all kind of just a big global family. I heard a fun comment over the last week. Somebody said that Houston, Texas is the gateway to the galaxy. And it made me think, it's like, wow, we think of like, Houston, Texas is big space city, but it's like, this is really going to end up just being a pit stop onto the bigger things that we go on to discover in the future. So, Fred, did you have anything else you wanted to add or commentate on the articles we talked about today?
Not really. I think we've covered them pretty well. But I would like to say, I think this is probably our last get-together for a while. It's been great talking to you. Actually, it's not quite the last because we've got a Q&A session to do as well. But in the main sessions, thank you very much, Heidi, for your expert handling of all our topics and the lovely questions that you've asked.
Oh, well, thank you so much, Fred. I appreciate that. And thank you to all the listeners who wrote in and said thank you, that I'm doing a good job. That certainly made me feel really nice. So thank you to the listeners. Thank you, Fred. And you will all have Andrew back next week. You get me for one more Q&A, but then you get Andrew back after that. So thank you so much. Until next time, everybody, this has been another wonderful, out of this world episode of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.